Energy is the ability of an object to produce a change in itself or the world around it. This does not mean that you are going to do that thing. It just means that you have the ability to do so. Okay, so you do not have to change your environment. You do not actually have to do anything. You just have to have the ability to do it. I have the ability to go run 5 miles tonight, but I probably won't. Okay, so that's the difference. The energy is just the ability of an object to produce a change. They don't actually have to do it. So we have two main types of energy that we're going to talk about. Our first type is called kinetic energy. And if you guys remember, kinetic means moving. Okay, so this is going to have something to do with moving. This is the energy of an object due to the object's motion. And it is measured in joules, just like work. Our kinetic energy formula is Ke equals 1/2 mv squared. Our m is a mass, our v is a velocity, our mass needs to be in kilograms, our velocity needs to be in meters per second, and our kinetic energy will be in joules. This formula, unfortunately, doesn't fit in the triangle very well. Okay, now let's try and solve a kinetic energy problem. We already did a little bit with this hockey puck, so let's kind of go back to this hockey puck. This hockey puck weighs 105 grams, or it has a mass of 105 grams. A player is exerting a constant 4.5 Newton force over a distance of 0.15 meters in 45 seconds. And then it says, what is the change in the puck's energy? Okay, so let's talk about what we know. We know that our mass is 105 grams. We have a force of 4.45 newtons. We have a distance of 0.150 meters and a time of 45 seconds. And they want to know what is the change in energy as it's moving, so that must be a kinetic energy. So the first thing we need to do is we need to convert this mass to kilograms. So to do that, I'm going to take 105 grams just so you remember what we're doing. I'm going to take 105 grams and I'm going to convert it to kilograms. So I have 1,000 grams on the bottom because there's 1,000 grams in 1 kilogram. And I'm going to take 105 and divide it by 1,000. I'm going to get 0.105 kilograms. The second thing I'm going to do is I'm going to find the velocity, because my kinetic energy formula is Ke equals 1/2 mv squared. So I need to find the velocity before I can find my energy. So my velocity formula is V equals d over t. This is from the beginning of the year. Our distance is 0.150 meters. And our time is 45 seconds. We're going to get a very slow velocity. I added an extra 0. Our next type of energy is potential energy. And we're really going to talk about gravitational potential energy. When we get to springs, we'll talk about potential energy of a spring, but right now we're just talking about gravitational potential energy. And basically, the higher you are up, the higher up you are on Earth, the more potential energy you have. So if this is a building and you're up here, you have much more potential energy up there than you do down here. Basically, the more it would hurt to fall, the more potential energy you have. Your reference level is just the position where potential energy is defined to be 0. So here we defined the ground as our potential energy equal to 0, but you could just as well say this was the potential energy equal to 0, and then this guy would have a negative potential energy, and this would have a positive potential energy. And our formula is potential energy is equal to mass times gravity times height. And you can put this in the triangle. You just have to make another spot at the bottom. Now let's talk about reference level. If we have, I'm going to try and draw this. I'm not a very good artist, but we'll try. So this is the ground. This is like a hole in the ground, and here's some more ground. Now we're going to have a tree. You see, that's decently brown. We'll have a tree. Of course, I need to make this tree have green leaves. So here's the leaves of my tree. Now I'm going to put some branches on my tree, and you'll see why in a minute. So let's put one here, maybe one here, and let's put one up here, maybe one here. Okay, so there's my tree. Now in my tree is a kitty. I'm not very good at drawing cats, so you're just going to have to bear with me. Here's his ears, his whiskers, his eyes, little kitty nose. He's got a tail. He's a fat cat. Okay, so there's our kitty. Now, let's put some distances here. Let's say this is 10 meters. Let's say this branch is 8 meters. Let's say from here to here is 10 meters. And let's say from here to here is 15. And this hole is like 2 meters. Okay, now let's ask ourselves some questions. Whenever we have our reference level, it's whatever, like we have this cat, and if we want to know his height relative to the ground, okay, that's going to be this 10-meter branch plus this other 10-meter branch. And so you'll get 20. Okay, but what if we wanted to know his height relative to that hole in the ground? Okay, then we would have still the 10 meters, still the other 10 meters, and then we'd have another 2 meters. So that could be 22. Okay, if we had our cat here, I'm just going to write cat instead of trying to draw him again. If I had our cat here and we wanted to know his height relative to the lower branch, his height would just be that 15 meters. Okay, so you can come up with all sorts of situations, but basically you really want to pay attention what they're asking the height is relative to what. Okay, so that's kind of what I wanted to show you here. Okay, let's try a potential energy problem. Okay, it says that we are lifting a 7.3 kilogram bowling ball from a storage rack and hold it up to your shoulder. The storage rack is 0.61 meters above the floor, and your shoulder is 1.12 meters above the floor. When the bowling ball is at your shoulder, what is the bowling ball's gravitational potential energy relative to the floor? So let's write what we know. We know that we have a mass of our bowling ball, and our mass is 7.3 kilograms. We have a height of the storage rack, which I'm just going to do HSR because shoulder also starts with an S. I'm going to do height S for shoulder. And then we want to know the potential energy. And again, energy is in joules. So our potential energy formula is PE equals mgh. Your mass is 7.3 kilograms. Gravity is 9.8 meters per second squared. And we want our shoulder relative to the floor. So we're going to use that shoulder height. If you multiply all of these together and you put it in your calculator, you should get 85.85 joules. And that's all you have to do to solve for gravitational potential energy. Now let's look at part B. Part B, we have the same things. We have our 7.3 kilogram ball, our height of our storage rack, the height of the shoulder, and then they say when the bowling ball is at your shoulder, what is the gravitational potential energy relative to the storage rack? So this one's a little different. So in this one, the first thing we need to do is find the relative distance. This is when that reference level stuff comes into play. And our shoulder height is 1.2 meters, and the rack is 0.610 meters. So the distance between them is 0.59 meters. Now we can go ahead and find our potential energy. So we have potential energy is equal to mass times gravity times height. Remember, our mass is 7.3 kilograms. Gravity does not change. We're still on Earth. Except now our height is going to be 0.59 instead of 1.12 like it was before.